Okay, this is Spice. Hello, hello. Oh no. It's, yeah, hello, hello, hello. Yes. Okay, I don't need to worry. Don't need to worry. Okay. Okay. Now, uh-oh. No, that's all right. Okay. We can start again. Sure. Wait, let me see what's going to happen. Just a second. So today we're going to cover two things. Okay? Roughly two chapters mainly. Uh, and we're going to do is cover new concepts that these are a few considerations that I want you guys to just read through once. I'll explain it afterwards. But it is the territory. Understood. So let's start from the basics. Okay, so we know that a body has a few fundamental properties. Okay, uh, such as its mass. You have then the mass and what else do you have? A body's weight. Let's say, okay? Weight. You have a body's, let's say, uh, mm, potential energy. Okay, these are kind of the properties, the fundamental ones, but these are multiple properties. While this is a fundamental property, these are kind of derived properties, right? In this we have this from mass we have weight, uh, and then the potential energy depends on the substance. If it is storing potential energy or if it is doing anything else. So now the way that charge is that the same fundamental property that we have as mass is um same property that we have for charge. This is a fundamental property that every object has. Now, as charge means, let's say, the type of mm, the nature of electricity. So that's a better way to put it. Now the nature of electricity can be two things. Okay, the nature we have two things. Okay, one is positive, the other is negative. Okay, now what happens is because the discharge, because there is a fundamental property, that means that there will be derived properties as well of this. And now the derived properties of this, the main one that we have is electric field. Okay. Now, electric field is somewhat, not exactly, but somewhat related to gravity. Gravity. Okay. See, gravity is a derived kind of a derived, so not exactly, but kind of a derived property of mass. Right. So more, let's say there's a huge mass out there, then you have gravity. Right. So it's kind of the same thing. Electric field is derived from charge. Then, yeah, now this electric field has consequences. As there are any concepts, there will be consequences. A field means as in the area around the charge, right? The field area. The way that a mass is. Let's say that there is this mass, okay, of m1. Now there will be gravitational pull around here. It will increase here, so it will decrease because we know that gravity is directly proportional to r over 1 by r square. So as you increase the radius with square, there will be decreasing gravitational force. Okay, now these have fields. Okay, now see these fields are kind of overlapping, and we know that unlike charges attract each other. Okay, so let me make this somewhat more simpler. Mm, we have uh, here. Let me think of it. How do I explain this part? Let me make it more simpler. Yeah, right relationship with gravity. That should suffice if we are simpler, but let's say that you don't understand gravity. But in that case, because of there are few fundamental properties which affect not only the body but the area surrounding the body as well. So these are as it's kind of um okay. So let's say introduction with its hard Hmm. Something more simpler than okay, I'll continue that. If something disorients space, it can be mass, it can be charge, it can be something like weight. Okay, we know that three-dimensional space, right? You have the y-axis, the x-axis, and the z-axis, right? So x, oh no, this is a y, x, and let's just yes. Okay. Now, if we are considering a 3D object placed in a 3D plane, okay, the most simple way would be thinking of this space kind of in two dimensions. Okay, yeah, okay. Two dimensions. Yes, there is a z component as well. Okay, so like for example, this is gonna be y, this is gonna be your x. Okay, and okay, it's a basically a space, an area of space. Okay, now what happens is when you keep something here like ball or anything which has mass, or it's usually said by mass. So I'm not 100% sure if this same thing applies to charge, but this is kind of related. That's why I'm explaining this. So if you put in this a body in this space, it creates this depression. Like this. Okay? The ball is here, here, right? And this, yeah, this is z-axis that you're seeing the depression. Okay, so the ball will be here, and as you go, okay, but as you put in inside, okay, it's going through inside. So, we hope that this kind of makes sense. Yeah, so it's inside. It's like a pocket. Okay, I was correct. Okay, let's show this. It's the caps was on for some reason. Uh, this is yes. Yes. So just like how mass affects the area around the body, it creates this depression. Okay? Now this depression, because something happened, it will have some consequences. Now the consequences here are it creates, since there is a, like, think of it like this. You have a cloth, okay? You stretch the cloth from four directions. Okay, you're stretching the cloth from four directions. Okay? Now, when you put in, let's say, a heavy metal ball in the middle of the cloth as you're pulling it, okay, from four directions, it will create this depression, okay, right? So, if that depression was created, like, excuse my drawing, but if that depression was created because of mass, then if you put in a body near your first mass, okay, let's say you're putting another body, okay, around here, this body has its own depression, okay. So let me just, this body too has its own depression, okay. This body is there, so there is this kind of depression. But since oh, yeah, sorry. Okay, let me just, okay. This body has its own depression. Now what happens is, because the depression of this magenta body is higher as compared to the depression caused by the smaller body, it will roll towards the greater body. This is what we specify as gravitation. Okay. Now this model was, if I'm correct, this model was proposed by Einstein or Newton. I'm not sure. This explains how planets orbit around each other, like how the moon orbits around the Earth, or how the Earth orbits around the Sun, and etc. Okay? I'm not going to go into too much depth with it. Okay, so let's say that there is a body, okay, which has mass. So it creates this depression, right? So the main idea is that charge has to be contained within something, and that something will always have mass. Right? Charge happens because of electrons, okay? Because of abundance or shortage of electrons. Now, we also know, let's say, don't know this, I'm going to explain it more in a more simplified way. Electrons have mass because charge needs to be contained in a place or else it will go everywhere. Okay, so when it is contained inside a body, that body has mass. Okay, that is why we say that electrons have mass. Not I don't know the exact numerical figure for it, but electrons have mass. But not all masses have electrons, like have charge. The electrons exactly charge. Okay. Okay. So all electrons have mass, but not all masses have charge. Okay. What electrons? What are electrons? Electrons, like the number of electrons, that means the, okay, electrons carry charge. Okay. When you consider an atom, I know we are going a bit off, but this will kind of make things easier in case you don't know anything. Okay. If you understand a few things, you can of course skip ahead. But I'm trying to explain this as simplified as I can. Now, what happens is when you see an atom, according to Rutherford's model only, there is a nucleus. Right? There is a nucleus. Now, this thing has protons, positive charge, neutrons, neutral charge. Okay. Now, there are a few things that you need to remember in order to, in order for knowledge to build on itself. Like it cannot be that you understand everything without memorizing anything. Okay, you need to memorize a few things in order to understand a few things. Okay, so here you kind of need to understand that in an atom there are charges present. Okay, now what happens is electrons flow around, right? We know that electrons flowing around, electrons flowing around. Okay, now what happens here is if the number of positive charge is equal to the negative charge, then we say that the charge on this is neutral. Okay? Now, but if we kind of cause an abundance in one, we create a shortage in one. Okay, like if we are creating an abundance of negative charges, then we are causing a shortage in positive charges. So, and the main thing about nature is it wants balance. Okay, so nature wants everything to be neutral. Okay? Now, if you are increasing the negative charge, the atom is going to try and take the positive charge from around itself or from other atoms, molecules, and so on. Okay? Now, we understand this part. I hope you did. Can I explain this in a more simplified way? No, I don't think. Mm, yeah. But if you're going to more detail, then we'll have a few more things like works. Yeah. No, that isn't that necessary. At least, because the main reason that I'm making this is that you understand the concepts. Now, the application of those concepts, you need to do that through practice questions, simplifying, and many other ways. Okay? So I'm just teaching you the concept, not the application. Like I'm going to be the applications you will be able to solve once you understand the concept. If you don't understand the application, then you haven't understood the concept. Okay, so I'm not going to do any questions. Okay, uh, yeah, this is just concept. Okay, now this charge, because we know that mass is causing a distortion in space. And we also know that if there is an increase in one charge, there is a decrease in the other. And since nature wants, how does this action? Nature wants balance. So what it's going to do is it's going to create a charge that it needs so that it can achieve neutrality. Okay? So this will affect the space around the mass. Okay? Around the mass, this will affect the space. Okay. Now, but this is a bit different on how mass affects the space. Mass causes a depression. Okay. And we also know that if there is charge, there will be mass. Okay. Now let's say that mass isn't there, just hypothetically. Okay. This is not what actually happens, but we are just considering so that we understand it a bit better. What happens is, oh my god, how many times will this crash? Okay. You have this space, you put in a body, it doesn't have mass. What it will do is, it will affect, because it wants to attain neutrality, it will affect the space around it. Because it cannot achieve neutrality by its own. It needs to get things from outside. Think of it like a factory. Okay? In a factory, okay, when you have a factory, in a factory things are made. Alright? In a factory, you are not going to grow your crops, right? So it will, the factory will take supplies from farmers, you have distributors, mm, mining agencies, and so on. And it will create a an end product. Okay? Now, these are things that it gets from the surrounding of the factory. Okay? Surrounding of the factory. We are considering this circle, the charge, to be this factory. Okay? It, let's say, okay, this factory wants to achieve a certain units of its end products. If it reaches that end unit, what will happen is the production will stop. The production will completely stop. Okay, but unless that unit criteria, the amount of unit that needs to be made, isn't met, it will keep on producing. Okay, so it will not end. That same way, this charge will keep on creating, like it will keep on affecting its surroundings. Just as the same way, the factory will affect the surroundings of food distributors and etc. Okay, until it reaches the state that it wants to reach, and in this case, it is neutrality. Okay, so now when you have a positive charge and you have a negative charge, negative charge happens when a body has more negative charges. Okay, it has more electrons. Okay, so what it can do is kind of there are theoretically two ways. The second one isn't theoretically correct, but this is sake for the sake of understanding or considering it. First is that it donates the excess negative charge that it has. Okay, so let's say giveaway. Okay, uh, it's a bow on a gift, use my drawing. Okay, and or second is that it gains more positive charge in order for it to balance out the negative charge. But the thing here is, if you're adding more positive charge, then you're changing the atom as a whole because you're affecting the nucleus of the atom. Okay? So this is not viable. Now this can happen. So positive charge happens in an opposite way. There is, as I said, if there is an increase in one charge, if there is an increase in one charge, there will be a decrease in the other. Oh no, I put the arrow facing upwards. It should be downwards. Oh, okay. No, not bad. So it will be something like this. The relation would be something like this. Okay. Now this needs to achieve neutrality. Okay. Not even sure if it is a word. Yeah, no, no. Okay. Now we know that positive and negative charges happen due to opposite reasons of each other. If there is more negative charge, then it means that the electrons need to be gifted. If there is more positive charge, then that means the electrons need to be received. Okay? Think of it like this. In your friend's birthday, if he has, let's say, a set amount of gifts that he can receive, okay? If he has a lower number of gifts which he can maximum at the maximum capacity he can hold, okay, and the amount of gifts that he has is lower than the maximum capacity, then you will give the gift, right? Yeah. So this is the case of when there is a positive. Okay. When something is giving its electrons from a negative to a positive. Now let's say your friend got more gifts than his maximum capacity that he can store them. Now what he has to do? He needs to give away those gifts. Here the gifts mean that there is more gifts means there is an excess of electrons. And electrons are negative. So it will give those electrons. Okay. So there are two ways. Okay. Now, so from this we know that the nature of the positive and negative charges are totally opposite to each other. Now, since there isn't, if we physically place a magnet surrounding iron. Okay, you might have seen those. They'll put magnetic soil on a paper and will induce an electric current that will cause it to go in circles. It will arrange the magnetic soil in circles. So the thing is, nature doesn't tell us exactly what the direction of the charges are. Okay, because of its charges, as I said before earlier, that these charges affect space. Because of them affecting the space, it causes electric field. Okay, so for convention, that means that we have considered that for a positive charge, the flow of the electric field would be towards the outside. Okay? And the flow of a negative will be towards it. Okay. So if we are joining these two electric fields, okay, it's not going to be overlap. It's not atoms. These are not atoms. You will get it. From positive, you go to negative. Positive, you go to negative. Negative, you go to negative. This is this is a convention. Okay? This is a convention that we have. Okay. Now, when we bring two like charges, they'll repel each other. They'll be like, no, I don't want you. Okay. You are same as me, I don't want you. I want someone different. Okay. And what happens is in life we can't always be like positive and negative like always. Yeah. Let's say we are bringing two charges which are of same charge, the same type of charge of each other. Now, first these will repel each other, right? If the more closer you're bringing them, the more repulsion will be present, right? So what happens is there is repulsion. Now, here comes another concept where this is important. You're doing work against the electric field. You're putting in external work. You're pushing the charges closer to each other, even though they are repelling, right? So in that case, because we are giving external work, we have defined this as electric potential. Now remember, this is different than potential energy. Okay, it is similar, but this is different than potential energy. Okay, potential energy is the energy stored in the body due to its state. Here, electric potential is a bit different in the sense that it isn't exactly because of the state, but rather it is because of the consequence that we are bringing two like charges together. Okay. Now, so the because at times we might need to collide positive same charge together for some type of reaction. Okay. So in order to make them touch or anything, we're going to measure that through electric potential. So like how much strength, quote unquote strength, do I need to make these two charges touch each other? And I need this external quote unquote strength is because these two charges are repelling each other. If they would have been unlike charges, due to electric field, they would just easily just would have attracted each other. Okay. Um. Now, so until now, we'll revise a bit. We have a charge are of two types, positive and negative. Okay. Now, these charges affect the space around them, okay, by creating a depression and affecting the environment. The depression is created because of mass, and the electric field is created because of charge. Okay, and by convention, we are saying that from an electric field goes from a positive towards a negative. That's convention. Okay. We could also say that it goes from a negative to positive. That is also theoretically correct. But if you are explaining, let's say there are two people, and one has the belief that electric fields go from positive to negative, and the other person has the belief that the electric field goes from negative to positive. Both are correct. But in order so that we can understand what we are talking about, we have adopted this convention that electric field goes from positive to negative. Okay, we're done till here. And we know that when again, when you really crash again, you need to see something. My computer is concepts. I mean, then how many? Okay. We know that unlike charges repel, and sorry, unlike charges attract and like charges repel. Okay. So if you are forcibly making two positive charges touch each other, then that external energy, because we're using some energy, right? For calculation, we need to consider that as well. That energy also needs to be considered for calculation, right? So we define that energy through electric potential. Okay? Now, here, so we can say that there are two cases. Okay? First case is that you bring two unlike charges and that you bring two like charges. Okay? In unlike, there will be attraction. Okay? Attraction. But in like, there will be repulsion. So in order to join or like touch these charges together, you will need external energy to combat that repulsion. That is known as electric potential. Okay? Here also attraction, we can consider electric potential to be present, but the thing here is that the electric potential for attraction, oh god, the case for electric potential during attraction would be equal to zero, because you're not putting in external work, you're not putting in extra energy, so that the charges can touch each other. Okay. Now, We have done. Okay. Now, we now question arises that these charges are pulling and pushing, right? These are happening because of electric field. But we did not mention anything about force because force is needed for something to be pulled or pushed, right? So here we are stating that there is a force present, which is called, where did we write potential? Okay, this, so what? Electric field. Okay, EF. Now these two, so electric force, and as we have seen in previously that almost every force has some law. Here also we have defined something known as Coulomb's law. Okay? You can memorize the formula afterwards, but I'm not going to get into the specifics, as the only time that I will go into the specific details is when if it strengthens the concept. If it is a detail about the concept, like it's a byproduct of the concept, then those details will not be covered in this video. Okay, so now we also know that neutral bodies can be charged, right? If you're seeing that there are only a few bodies where electricity present, then well, that's not how it works, right? If there are conductors, which means they allow the passage of electricity. That I'll explain how. And then we have another class identified as dielectrics, where these do not allow the electrons to flow, so current doesn't flow. So the charge is always neutral on them. There is a specific charge in conductors. There is no charge in dielectrics because the detail I will cover in a minute. Okay.